Welcome back to G Fun Facts Online, your go-to source for the most fascinating insights from the world of science and tech. Today, we're diving deep into a technology that sounds like it's straight out of science fiction, but is rapidly becoming a reality: photonic computing. You know how artificial intelligence is everywhere, right? From your smart assistants to complex scientific research, AI is transforming our world. But there's a catch. This AI revolution is incredibly power-hungry. Traditional electronic systems are starting to sweat, struggling to keep up with the demand for more speed and better energy efficiency. So what's the solution? Well, imagine computers that think with light. That's the promise of photonic computing, and it could be the key to unlocking an even more powerful and surprisingly greener future for AI. So what exactly is this photonic computing? At its heart, it's a radical shift from how computers have worked for decades. Instead of using electrons, the tiny charged particles that power all our current electronics, photonic computers use photons. Yes, the very same particles that make up light. Think of it as swapping copper wires for fiber optics, but on a microscopic, computational level. This isn't just a minor tweak. It's a fundamental change that brings a whole host of advantages, all thanks to the unique properties of light itself. Now you might be asking, why light? What makes photons so special for computation, especially for AI? Well, there are some truly compelling reasons. First up, unparalleled speed. Photons travel at the speed of light, which, as you know, is the universe's ultimate speed limit. This means calculations could happen significantly faster than with electrons, which bump their way through resistive materials. Then there's massive bandwidth and parallelism. Light waves can carry multiple streams of data at the same time, using different colors or spatial modes, a concept called multiplexing. Imagine a highway with an almost infinite number of lanes, all moving at light speed. This allows for a huge number of calculations to happen simultaneously, which is exactly what AI algorithms, with their complex matrix operations, desperately need. But here's a really big one: exceptional energy efficiency. Electrons moving through wires encounter resistance, which generates heat and wastes energy. Photons, on the other hand, zip through optical pathways with minimal resistance and generate far less heat. This means dramatically lower power consumption. We're talking about tackling one of the biggest criticisms of large-scale AI: its massive energy footprint. Some designs are even aiming for efficiency improvements of 100 times over today's leading GPUs. Add to that reduced latency, quicker results, and immunity to electromagnetic interference, which can plague electronic circuits, and you've got a recipe for a computational revolution. Okay, so how do photons actually compute? It's not magic, it's clever engineering. The workhorses here are photonic integrated circuits, or PICs. These are microchips that cram various optical components like lasers, waveguides, modulators, and photodetectors onto a single chip, much like electronic integrated circuits. And a leading way to make these PICs is using silicon photonics, which cleverly adapts existing silicon manufacturing processes. Inside these PICs, computations happen using cool principles. One is interference. You know how waves can combine to become stronger or cancel each other out? Light waves do this too, and engineers can precisely control this interference to perform mathematical operations. Another key technique is wavelength division multiplexing, or WDM. This uses multiple colors of light within a single waveguide, each carrying a different data stream, allowing for that massive parallel processing we talked about. This is especially powerful for optical matrix multiplication, a core operation in many AI deep learning models. Photonic circuits can do these multiplications incredibly fast. Researchers are exploring different flavors of this. There are optical neural networks, ONNs, which are PICs specifically designed to mimic biological neural networks using light. Then there's analog photonic computing, which uses the continuous nature of light waves for tasks like image and signal processing, and digital photonic computing, which uses photonic logic gates, like electronic ones, but with light pulses for binary data. So, how does all this translate to powering faster and greener AI? The demand from modern AI models, especially those huge large language models, is really pushing traditional hardware to its limits. Photonic computing offers a direct answer. For faster AI, think accelerated training and inference. By doing those crucial matrix multiplications at light speed, photonic processors can slash the time it takes to train AI models and get them to make predictions. Some experimental chips have even completed key machine learning computations in less than half a nanosecond. This also opens the door for more sophisticated real-time AI, like in self-driving cars or advanced robotics. And for greener AI, this is huge. The energy guzzled by AI is a serious concern. Photonic computing's inherent energy efficiency means a significant cut in power needed. This directly leads to a smaller carbon footprint. Plus, less heat means less need for massive cooling systems in data centers, saving even more energy. Companies are aiming for truly dramatic cuts in energy use. The field is moving fast. Companies like Lightmatter have developed photonic processors running complex AI models with impressive accuracy and efficiency. Their system uses a hybrid photonic electronic design. MIT researchers are also making breakthroughs with fully integrated photonic processors. Lightelligence has created a photonic arithmetic computing engine, and other innovators like Salience Labs, Wave Photonics, and Ipronics are all pushing the envelope. Even the big players like Intel and NVIDIA are investing heavily in optical tech, recognizing its importance for the future of high-performance computing. Of course, it's not all smooth sailing. There are challenges. Manufacturing these precise photonic components and integrating them onto chips is complex and can be costly. Scaling these systems up to handle massive AI models while maintaining reliability is another hurdle. And for now, these photonic systems will likely need to work alongside existing electronic systems, which means efficient optical to electrical conversion is key. Developing effective optical memory and efficiently performing certain nonlinear operations crucial for neural networks are also active areas of research, though progress is being made. And, like any new hardware, we'll need new algorithms and software tools optimized for photonics, though standard AI frameworks are being adapted. So, what does the illuminated future look like? In the near term, say the next 1 to 3 years, we're already seeing optical interconnects making a difference in data centers. In the midterm, 3 to 5 years, expect co-packaged optics, where optical I/O is integrated much closer to processors, to become more common, along with specialized optical accelerators for AI tasks. The first general-purpose optical processors might even hit the market around 2027 to 2029. Looking further out, the big dream is all-optical computing, though that requires more breakthroughs, especially in optical memory. If we get there, photonic computing could truly revolutionize everything from data centers and autonomous systems to drug discovery and scientific research. Photonic computing is at this incredible crossroads of physics, engineering, and AI. By harnessing the fundamental power of light, it offers a very real path towards AI that's not just faster and more powerful, but also much more sustainable. The challenges are real, but the pace of innovation is breathtaking. The fusion of light and intelligence is set to unlock new frontiers, shaping a future where computation isn't a bottleneck, but a brilliant catalyst for progress. That's all the time we have for today on G Fun Facts Online. I hope you're as excited about the potential of lightspeed AI as I am. Join us next time for more amazing insights from the cutting edge. Thanks for listening.